Hello everyone and welcome to another tutorial. Today I'm going to show you the MG996R servo, the high torque servo, and show you how to use it. This tiny here is the SG19. I'm just showing you the difference between the two bodies of the servos. As you can see, the difference is quite enormous. This servo here is an upgraded version of the MG995. It comes with an upgraded shock-proofing body and much more accurate IC system control. The motor and the gears are metal, and they were upgraded too for much more centering. This servo comes with a total of 4 different headers. This one mounted here is number 1. This is number 2. Number 3. And number 4. This servo comes with female connectors with 3 different colors. The yellow is the signal, the red is the plus, the brown is the minus. This servo can operate from 5 volts to 7 volts. It's a high torque servo that can lift around 9.5 kilograms to about 11 kilograms. His speed is about 0.17 at 5 volts and about 0.14 seconds at 7 volts. And after all that being said, let's go and test it. To control the servo motor, you can just do this sample schematics. As you can see, I'm using a great program called Fritzing. It's free, and with it you can do a lot of things like this schema here. This is my servo. As you can see, this yellow wire here is the signal I'm putting in my Arduino Nano port D4. This is the VCC and this is the ground. As you can see here, I have a 10K potentiometer. If you don't know what a potentiometer is, it's a variable resistor. In my case, it goes from 0 to 1000 ohm. That's what 10K means. So now let's go and see the code. This is the code. I actually take it from Arduino.cc. You can find a lot of great things there, so maybe if you're lost or something, you can check their websites. I'll put it in my description. So to control the servo motor, you have you need to do 4 important things. Number 1 is to include the library. It's servo.h. Second is to make a servo. In my case, I'm using my servo to type servo. This is the servo that I'm going to move. So here I'm making 2 variables. This one here is belong to the potentiometer pin. It's A0. Here it's A0, analog A0. Here it's the value that I'm going to move the motor with it. So in setup loop, I'm just making my servo point attach at 4. So what this mean? Okay, so here is my servo that I defined, and attach is like I'm wiring to pin number 4. It's D4. So I'm just making a serial point begin, so to show me the position of the angle where my servo is. So I'm putting a variable val is analog read port pin, so I'm just going to read the value that's coming from the potentiometer. If you don't know, the value is between 0 and 1032. So here is I'm mapping the value. So what does this map function do? So you need to make 5 things. Number 1 is to declare the value that you're going to map. Second is making this here is the smallest value. Here is the greatest value, the maximum, the minimum, and here you just like changing the value between 0 and this number
to 0 and this number. So you're just scaling or mapping the value. So in the end, if I move the potentiometer to like the maximum, which is this number here, I'm just only going to get this number here. So in serial print ln var, I'm just going to output the current position of the servo, and here I'm just telling the servo to move. So it's my servo here. Remember, I'm just declaring the servo here. I'm using it here and here and here. So I'm going to make servo point right var. So I'm just telling the servo, which I name it my servo, to move to this position. So after this code, let's go and see how it's working.
After uploading the code to the Arduino, I'm making the necessary wiring. As you can see here, this is the D4 and this is the A0. As you can see, while I'm moving the potentiometer, the servo is moving. I can choose the exact angle of the servo using this 10K potentiometer. This is the great way to test your servo. So if you like my video, please subscribe my channel.